Hello, this is Elmer Santos, the Robofest Technical Director. I am here today to present the um, judge training for this year's game, Building Bridges. So, judges, thank you so much for judging Robofest. Here's our agenda. We're going to go over the game details, the site host and judge roles and responsibilities, the impounding process of violations, um, procedure to play rounds, scoring, and then unknown task and factor examples. In the training material, slides with a blue background are copied directly from the game rules, and then slides with a white background have been prepared for specifically for this judge training. So here's the scenario. Robots build bridges by performing precision tasks such as positioning heavy materials. They improve safety, efficiency, and accuracy through autonomous operation and collaboration with human workers. Here's a synopsis of the game. We're going to build a bridge to one of three locations. We're going to move footing one into position. We're going to span the bridge with two beams and then deliver a test load across the bridge and into the other side footing. It's a 2-minute maximum time for the game round. All tasks must be done autonomously. Unknown tasks and factors will be unveiled before 30-minute work time. It may include the target bridge location, the robot starting orientation, start line location, the bridge beam 2 location, the Tesla location, and the game ending robot location and task. Next, we just have some game definitions. The UTF stands for unknown task and factors, which are announced 30 minutes or prior to the 30-minute work time. And they include the start orientation, the location of some of the objects, and the game ending task. Those are shown on the screen, and a hard copy is provided to teams and judges. Work time. That's the 30-minute period before each round, where teams adjust their programs and have time to practice. The pit, that's an area for of team work tables. Only team members are allowed. Impound, the process of inspecting team's robots for compliance and then placing it on a placemat with the identifying information. Impound area, that's the table where near the official fields where robots are placed for inspection. A run, it's a 2-minute period where the robot competes, and then there are 2 rounds often called R1 and R2. The field, that's all the materials, including the 6-foot table, the river, the bridge footings, the beams, and the test load. Footing 1, it's a 1x2 piece of wood. It's 30 centimeters long. Footing 2, it's a structure made of foam board, any color. The river is a dark piece of paper. Bridge beams 1 and 2 are 25 centimeter 1x2s with the center line marked. Test load is a tennis ball. And then there are start line and cross lines, and they're made with black tape. And we also use object markers, basically white hull reinforcement stickers. And then transparent tape is used to secure the footing 2 to the river and to the table. And then lastly, a scorecard, which is what judges use to calculate the points for a run. Yeah, this is what the field setup looks like. The robot must start with at least one wheel touching the start line and also touching bridge beam 1. The robot starting orientation is required to be a certain way, which is unveiled before work time on the unknown task and factor sheet. And then the robot location on the start line is at the team's discretion, so it can be anywhere along the line as long as the orientation is correct and the one wheel is touching the start line. And then the actual bridge beam location is also at the team's discretion. It just has to be touching the robot in some way. So it can be touching the robot, then touching the table. It can be in the robot gripper, or it can be on board the robot. Those are all allowable. Okay, footing one will be placed along the black line, right covering the white marker, object marker. Bridge beam 2 will be west of the starting line. The exact location will be specified on the UTF sheet. It'll be flush with the north edge. Then the test load will be on the start line. And then the bridge could be at one of 3 locations, which will be specified on the UTF before work time. Next, we have the site host and chief game judge responsibilities. First of all, to review all the game rules and judge training, to recruit and train volunteers, to set up the competition location, which includes the registration area, the pit, the official playing fields, impound area, spectator area, and then to verify that the fields are set up correctly. Also to verify the placement of the objects on the tables after impound. The manager assigned the impound process to judges or proctors to manage the teams in and out of the inspection or impound area for each run. So they must determine the team order for each round, call the teams, start and end each run, instruct the teams to return the robot to impound. Responsible for validating scores. A lot of times this is delegated to the scorekeeper, but it's very important to make sure that scores are checked and validated. Award certificates and medals to teams and trophies to the winners. And then finally to coordinate the group photo at the end. Judges' roles and responsibilities. Review the game training and game rules. Proctor the teams during the events. So remember, no adults in the pit during the competition, and no adults in the pit or spectator area, and no contact during the work time. Then teams must share the official and practice tables. Impound the robots. We'll get into more details later. And then judges must review the UTF sheet for each round to determine the robot starting orientation and the specific game ending task. Judges must work with their partner judge to guide the teams at the start, watch for violations, reset the field if there is a request. The teams can be asked if they wish to be reset, and judges to reset the field materials quickly while the team member resets the robot. If it appears the team will score more 100 points, the judges need to record the time. After the round, they score the run on the scorecard, review the scorecard with the team for agreement, sign it, and then get the team's signature as well. And then finally turn in the scorecard to the scorekeeper. Next, I'd like to go over the robot impounding process. So first, we would like only one team member to bring the robot for impound. This is especially important at the larger events. Judges will be provided with the measure board to measure the robot for size compliance. Judges should handle the robots as little as possible, so ask the team members to help with that. Judges will check the robot for maximum size, including expansion. Wires are not included in this requirement, so that excludes wires. During The inspection for sized all the wheels for driving must touch the table surface. The robot must be labeled in accordance to our rules, and then robots may not be charged at impound. Yeah, robots should be turned off to save battery. After the inspection approval, ask each team member to place robot on their designated placement on the impound table. Game details for task and scoring. All items are to be checked at the end of the round, with exception of the robot start orientation, the test load delivery, and if there was a reset. Right, so most of it is scored at the end of the round. Robots must start in the unveiled orientation as instructed on the UTF. And then just a reminder, the location along the start line is up to the team. One of the tasks is to move footing 1 from the original location into a position that will hold the beams. If it's in the correct location, they'll be given 15 points. If it's partial, it'll be 10 points. Yeah, we'll go over this in some more detail in the next few slides. The other task is to deliver bridge beams 1 and 2 to the footing to span the river. Each beam is scored separately. And then deliver the test load to the bridge and roll it across the bin across to the bin which is in footing 2. And then finally, to complete the end task, and then we're separating them again this year. There's 7 points for stopping in the correct location according to the UTF, and then 7 points if it's stopped and then has correctly displayed the answer. Okay, here's some more details for scoring with some visuals. So moved in the correct location, right? It's on the line with some part between the marker and the edge of the table. It's okay if some part is like on the edge or hanging over the edge, or even hanging on this side of the of the marker, as long as some part is on the line in the right place. Right? If it doesn't satisfy that, it can get teams can get credit for moving. Right? So as long as the sticker is visible, right? The beam can be in the river, it can be right on other parts of the table. And then if it's not moved, if you can't see the sticker, then there's no points. Okay, bridge beam scoring locations or scoring examples. So spanning the river with perfect placement. So one end is on each footing, and the tape mark is fully covered, right? So you got a couple of examples here, right? The wide end, the narrow end of the beam, but it's touching both, and you can't see the tape. If that's not correct, then you can get points for correct location. Similar, except for you see parts of the tape. And then the next level is if it's touching one end of the footer, but not the other. Or yeah, it's on one end of the footer, but not the other. And then lastly, you get partial credit for if it's moved, if it's the sticker is visible at the end of the round. Okay, violations, full reset, and end of the round declaration. So when any of the following occurs, the judge shall stop the gameplay immediately, and the robot if it's still moving, to avoid further disruption. So if it's touched by the human, if it falls off the table, or if anything else, the judge determines. The team can request a one-time full reset with penalty at any time. If it reset is selected, the time will continue. while the judges reset the field and the team resets the robot. Teams may also declare the end of the run at any time. Players should not move the robot until instructed by the judge, right? The judge needs to score it first. If the robot is still moving when the team calls end of run or at the time limit, no points will be awarded for the game-ending task, which requires the robot to stop. All right, so next I'd like to go over the scorecard. So the first thing to score is the footing, and it can be only one of these at most, right? It's either in the correct location as we covered or moved. Bridge beams, right? We've got two bridge beams, but same criteria. For maximum credit, it spans the river with perfect placement. If it's not perfect placement, you still get 15 points for the correct location. If not that, then 10 points if one end is on a footer. And if not that, then if it was moved from the original location. So it's similar criteria, same criteria actually for bridge beam 2. The test load, again, this is one of the things that must be judged during the round. So if it's placed on the bridge beam before the midpoint mark in the beam and then rolls into footing 2, you get maximum credit. If it's placed on the bridge beam and the ball is placed after midpoint, you get partial 17 points. If it is placed on the bridge, but it doesn't roll in, it just remains on the bridge, you get 15. If it's not placed on the bridge, but just placed directly in the footing 2, you get points. You get 12 points, but it's not as much as if you've done it the way it was intended. And then finally, if it is the ball is moved from the original location, you get 10 points. Okay, next, the game-ending task, again, is divided into two sections. You evaluate whether it's in the correct location, according to the UTF, and whether it's the correct answer is displayed. And then the next item, if the robot remains intact during the run, you get 11 points. And one of the questions that's been asked, if the robot comes apart, the team does a reset, but it's intact at the end of the run, they still get credit for this item, but they lose credit for the item 8, right? Because they would have to do a reset. And then if there's any field damage, it's minus 15. I would suspect the only real potential for field damage or large potential would be the footing 2, which is made of foam board. Here's an example of the scoring spreadsheet. Right, this is what the scorekeeper would be done. It's provided by the Robofest office. You basically have the team name and ID. You score each round. We want to know whether the end task was successful, right? So if both parts are successful, it's a yes. If only one is successful, it's still a no. And then if it's looks like it's 100, perfect round, then we want to know the time left. Right, so we just have to fill in these parts, right, in this area, and then the spreadsheet should do the rest. And then we have some other hidden cells that help with the ranking and the tiebreakers. Next, I would like to go over examples of UTFs, first with a junior. So note, the actual UTFs will be different for each round and may include different stopping locations, conditions, measurements, calculations from these examples. But these are examples of what, you should see something similar to these examples. So first off, we'll unveil the robot required starting orientation, in this case facing west, right? Reference the compass. Bridge location, in this case facing in the south location, right, along with the footing 1. And then dimensions of X and Y are unveiled for junior. And let's see, and then finally the game ending task, right? It's going to be some sort of math problem. In this case, and location specification. So in this case, it says with some part over the intersection of the black lines right here. And then the answer to this question, and we try to make it so they don't have to print the units, just the number. Okay, next we have an example of a senior division. This is slightly more challenging. So for seniors, there's certain things that are not really unveiled until after impound, right? So before impound, this is what they're given. They're given the robot starting orientation facing north in this case, the bridge location, which is on the east side in this case. And then instead of giving X and Y, it's kind of like a problem. X is between, right, 50 and 90, and then Y is some function of X, right? So they have to somehow measure X, and then by doing that, they'll know where Y is. Similarly, for senior division, the math equation involves the robot having to determine some bit of information on the field, in this case, X. So hopefully that gives you a good idea of the unknown task and factors for senior versus junior. All right, looks like that's it. I'd like to thank our game committee members, Mr. John Arnold, Dr. Cartwright, Professor Peter Gunther, and then Mr. Steve Criscala. If you have any questions, please send them to robofest@ltu.edu. So I hope this judge training was helpful, and I wish everyone the best of luck. Thank you.